The James Webb Space Telescope is revealing the universe like never before. Our planets, the furthest galaxies, and the strangest phenomena.
And what you can see is actually material falling into a black hole.
And that's only in the first few weeks. There's going to be a lot more discoveries to come.
The James Webb Space Telescope is a product of decades of hard work from scientists around the world.
I have been waiting my entire astronomy career for JWST. It is absolutely revolutionary compared to what was available.
It's very, very rare in science that you make a big step forward in your measurement capability in the way that JWST has done for astronomy. And it just doesn't happen very often in the history of science, and that's really exciting and significant.
One of the things that makes James Webb so special is its gigantic mirror.
So that there are various things that make the primary mirror on James Webb special and incredible. I mean, the first is the sheer size of the mirror. It's the largest one ever launched.
The Webb mirror is around 6.5 meters in size. So if you can imagine that, that's bigger than most houses that you're walking by.
It's so large it wouldn't fit in the rocket, so they had to devise a way of folding it up so that it would fit inside the top of the rocket.
It's absolutely humongous. And that makes a really big difference in terms of the sensitivity of the telescope.
Well, it's thousands of times more sensitive than Hubble. It's a step forward of factors of 1,000 or more. Factors of several thousand, in fact. I'm correcting myself.
The bigger the mirror, the more light you collect. The bigger the collecting area, the more sensitive you are and the further you can see.
The other thing that makes it absolutely incredible is the precision with which it's been made. If the mirror was stretched to be the size of the United States and you were to measure the size of the biggest bumps and dips on the mirror, you're only looking at a bump or a dip of order 1 centimetre in size. It's absolutely incredible, and that's what generates the near-perfect images from the primary mirror.
But it's not just the mirror that makes the images from James Webb so incredible. It's also the type of light that it detects. The James Webb Space Telescope detects infrared light, which is a wavelength of light that we can't see. But the unique properties of infrared make it incredible for exploration.
So with the infrared light, you can see the atmospheres of exoplanets. There's molecules in star formation regions, things like caffeine and alcohol and water ice, the signatures of life around other planets.
So just a few things then. Infrared opens up the possibilities for astronomers like Olivia and allows them to capture images that would previously be impossible in the optical range. But even within the infrared spectrum, there are multiple different wavelengths. On board Webb, there are 3 instruments that observe near infrared. This is closer to the visible spectrum. But the instrument that's garnering the world's attention is the mid-infrared instrument on board JWST, known as MIRI.
MIRI is essential for JWST. Without it, you can't see the cooler phenomena in the universe. You can't peer back into the earlier stages of star formation as you would like.
So MIRI is an incredibly significant and important instrument. The image contains far more detail than has ever been done before.
So when we look at it in a new wavelength of light, we find things that we hadn't expected to see, and that's a really important part of how you discover things about the universe.
MIRI allows us to see further along the infrared spectrum, and this in turn allows us to see through dust clouds and further back in time than ever before. That's because as galaxies move away from us, the colour they emit shifts further into the infrared, so the longer the wavelength we can observe, the further back in time we can see. But despite the capabilities of MIRI, it very nearly didn't make it on board James Webb.
So MIRI wasn't initially part of those plans because it seemed technically very complicated, and I think people were thinking about the science in a slightly different way. And so I started making the case that really we needed to add a mid-infrared facility to the telescope.
Gillian Wright is the European Principal Investigator for MIRI and the Director of the UK Astronomy Technology Centre, and was instrumental in pitching to get MIRI on board Webb.
When I found out it was confirmed that MIRI was going to be on board, I remember being very happy and also knowing that I was going to be very busy for a large number of years.
Gillian wasn't wrong. Construction of James Webb Space Telescope started in 2004, and 17 years of work later, on Christmas Day 2021, with MIRI securely on board, the telescope finally launched.
And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
I've been looking forward for the Webb launch for many, many years. And as it got closer to Christmas Day, I was extremely nervous. I don't think my family enjoyed Christmas morning with me because I had on the TV the Webb launch playing, and I was quite nervous. I had my pillows ready in case I needed to hide.
Everything went perfectly. It was an incredible launch. It was a pleasure to watch.
So it was a very good Christmas present.
It was a lovely Christmas present, it really was.
Over the next few months, the James Webb Space Telescope travelled over 1.5 million kilometres away from Earth to its new home, gradually turning on the instruments along the way.
So then it was getting really exciting because we've been from Christmas Day all the way through until the late spring when MIRI finally gets turned on.
As the instruments are being turned on, it's both exciting and it's nerve-wracking because you know that there could be things wrong.
After decades of work, the James Webb Space Telescope was finally operational, and it wasn't long before the images started coming in.
I knew when Webb was going to take its first images, they were going to be spectacular. What had not prepared me was just how spectacular they were going to be.
The first images were just incredible, just so beautiful. It was amazing.
And then when the first images came back, I was just absolutely astounded at how good everything performed. And I've been smiling ever since. It's almost emotional.
The images are spectacular. And the only thing more spectacular than the images are the discoveries that lie within them.
So one of the things I think that's really exciting about the early images is the way they show how MIRI really adds information.
I can see details in there that I knew existed, but I never thought I'd be able to see with a scientific instrument. Some of the first Webb images released were of the Southern Ring Nebula. This is a planetary nebula, which is a star at the very end of its life. In the MIRI image, we see actually a second star. So we can see a red star and a white star. So these are actually a binary system, and that's the very first time we've seen this binary companion in the Southern Ring Nebula. This is an image of Stephan's quintet, 5 galaxies that are interacting with each other. And what you can see in this galaxy up here is actually material falling into a black hole in an active galactic nuclei. You can see the material in the galaxy is actually orbiting and falling into the galaxy itself. This is 13 times further than what we've been able to see before in the infrared.
I mean, JWST has already found the furthest galaxies we've ever seen, the highest redshift ones, the closest, and that's only in the first few weeks of operation, and that's really exciting, and I think it's an indication that there's going to be a lot more discoveries to come.
With Webb, we've designed it to answer many of the questions we already know about the universe. But as with all new telescopes, there's a realm of new discoveries.
The mysteries that will arise, I think they're really exciting.
New questions to answer.
The questions we don't know how to ask just now, and I think that's really exciting to see something that not only has nobody ever seen it before, but nobody expected to see it.
I feel very privileged to be part of this.
I'm proud to be part of JWST. It's been an amazing journey and a fantastic privilege, really, to be part of it.
I think it's just incredible. I helped make that instrument, and when I see these images, I'm just full of smiles.
We lost comm with the spacecraft.
If the spacecraft wasn't back up and running by the time we flew past Pluto, our 9-year wait would have been for nothing.
There's a little bit of drama because this is true exploration. New Horizons is flying into the unknown.
When we got there, we saw something that absolutely blew our minds. It was incredible. When we saw these photographs of what it actually looked like, really a world in its own right, it was mind-blowing. There was active geology on Pluto right now. Something so far from the sun should just be a cold, dead world, but it's not. It had this living, breathing heart.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade.
We've been using the best telescopes that we had available to us to observe it for years, most notably the Hubble Space Telescope. And through a lot of observations, a map was made of Pluto's brightness, but it was very fuzzy. You have some light periods, some dark bits, but that's all we had. The Voyager spacecrafts that explored the rest of the solar system didn't go past Pluto. We had to send a dedicated spacecraft to go and have a look at Pluto because we'd never seen it before. I mean, lots of people move their personal life around their work, and mine's no different, but it is different in the sense that, you know, the spacecraft goes past Pluto once in your lifetime. And so we arranged our wedding ahead of that, and then we actually decided to wait to have children until after Pluto. When you have a mission like Pluto, you have times where you really are quite busy on the mission. You're taking new data. We flew past Jupiter, that gives you data. We're looking at the stars to make sure our instruments are still operating and they're healthy. But there are periods whereby, you know, the spacecraft is in hibernation, it's spinning, it's not taking data. If there's a problem, it knows how to call us, but other than that, it's just marching forward towards Pluto.
We lost comm with the spacecraft. Totally silent. And so you can imagine when you're in any kind of critical situation, the worst thing is lack of any information. And that's essentially what we had.
Pluto Ace, Mom, on New Horizons Pluto 1. Could you advise why we are not locking up to telemetry?
About the 4th of July, so American Independence Day in 2015, it goes into safe mode. It just stops doing anything except pointing back to the Earth and telling us there's a problem.
Mom, Pluto Ace, stand by. I'll check with the station on the status of telemetry.
So to put that into context, our encounter is 10 days at this point out, and it's a flyby. We're going to go past Pluto once. We're not going to slow down. We're not going to stop. We're not entering the system. We're flying by it. If the spacecraft wasn't back up and running by the time we flew past Pluto, our 9-year wait would have been for nothing.
Station 43, Pluto Ace.
Mom, on New Horizons Pluto 1. Go ahead, Pluto Ace.
We found the spacecraft. It was responding to us. It was giving us information, but it was in a state that could not accomplish the encounter with Pluto.
It takes 9 hours to talk to the spacecraft at that point. And so we were doing the tests on the ground, making sure that the sequence that we were going to upload was working.
It took us 3 days to do that. Around the clock, we slept in our offices. No one wanted to leave because we had waited all this time, and there was no way that we were going to let this opportunity slip by.
And it will transmit a message back to the Earth for about 20 minutes, in which we'll find out how it's doing. But there's a little bit of drama because this is true exploration. New Horizons is flying into the unknown.
So before we entered the Pluto system, we downloaded the highest spatial resolution observations we'd made to date. So there's only 5 of us in the whole world that had seen this image of Pluto.
Oh, my hair looks better like that.
And we're all just sitting there at that moment of like, whoa.
We've recorded data of the Pluto system, and we're outbound for Pluto.
To see that was just incredible. It was a life-changing experience.
Look what we accomplished. It's truly amazing. Humankind can go out and explore these worlds. And to see Pluto be revealed just before our eyes.
So when you see an image of a new world, especially one as diverse as Pluto, there are so many things you can take home from it. And one of the first that jumped out of me is that heart-shaped region that's in the middle of the encounter hemisphere. And in particular on the left-hand side of the heart, it's very smooth. And you don't get smooth regions on any worlds unless there's some form of active reprocessing. And so there was active geology on Pluto right now. Couldn't believe it. Still can't really. So why is it so geologically active? We still don't have all the answers. Does Pluto have a subsurface ocean? There was mountains with holes in, which points to the idea of a volcano. Maybe it's a cryovolcano, a volcano that erupts ice. And that would be better explained if there was enough heating to sort of maintain a liquid water ocean. Pluto's really cold. Really, really, really cold, colder than you could possibly imagine cold. It's so cold that water there is sort of the bedrock. The ice is so hard it can form mountains, which is something that of course just couldn't occur on the Earth. And so on Pluto we see these big ice structures. So it all kind of implies that there's lots on Pluto that is quite fresh and new. And so whether you could have life that is in a sort of this contained place, subsurface, so dark, but with an energy source, it's hard to imagine from what we know of life. It's not impossible, but it's going to be a difficult thing to get to see because it's so far from the Earth. We don't want to do any harm. You certainly wouldn't want to send, a probe into this pristine world because you could kill everything that was in there just as you discover it. So it's definitely the thing of sci-fi, and it's fun to think about, but it's going to be a really difficult thing to test. Anyone that's been working at home during this lockdown will understand the frustration of limited broadband. And we have this on New Horizons because the spacecraft is so far from the Earth. Getting a signal back is so weak. It's meant that our 6 gigabytes of data that the spacecraft took during the encounter is still being downloaded. You're really trying to make sure you have everything on the ground before it gets wiped from the spacecraft, before it's gone from humanity forever. You want to make sure you have everything. True exploration isn't something that normal people get to do, right? I've got to explore worlds that have never been seen before. And I think once you've had that taste, it's just, you can't let it go. It's not quite adrenaline junkie stuff, but you want to do it again. And so it would be absolutely incredible to do it twice in a lifetime. What a privilege.
Very first data we got from Parker Solar Probe, for maybe 15 minutes, we were thinking there is something wrong with the instrument. Only to realize that no, the instrument is working perfectly, and actually what we are seeing is physics. It's physics that we have not seen before.
The Sun is the most important celestial body in space, at least to us here on Earth. It drives weather, ocean currents, seasons, the climate, and without the Sun's heat and light, life on Earth would not exist. But we don't understand it as well as you might think. That's where Parker Solar Probe comes in, NASA's first ever mission to touch the Sun.
It's a voyage of discovery. It's a groundbreaking mission. It is steeped in history.
This is Nicola Fox, the Director of Heliophysics at NASA.
So the concept of Parker Solar Probe has been around for over 60 years. And so, it's been the most high priority science for us to do, but it was always so challenging technically. And then, finally the technology catches up with the scientists' dreams and we're able to really achieve the mission. But nothing about Parker Solar Probe was easy.
Not only has the probe travelled nearly 90 million miles closer to the Sun than Earth, but it's had to withstand temperatures of over 1400 degrees Celsius. Keeping it cool is the job of thermal engineer Betsy Congdon. How hard could it be?
So the task of designing a heat shield for something that's going to the Sun is immense. Anytime you're trying to do something that has never been done before, while it is really exciting, it is also very stressful. One of the things when you're designing something for space as an engineer is you actually want to keep things quite simple. The Parker heat shield is about 4.5 inches thick.
Yeah, just 4.5 inches is protecting this probe from thousands of degrees Celsius.
The Parker heat shield is about 4.5 inches thick, and on both sides there is a material called carbon-carbon. It's a lot like the graphite epoxy that you might find in your golf clubs or in a tennis racket. And then in between is carbon foam. And so that together, as basically just a big sandwich, is what protects the probe from the Sun. As Parker Solar Probe approaches the Sun, and it's in its last approach and closest approach, the front side of the heat shield will be at 1400 degrees Celsius. But the probe itself, the spacecraft, where all the electronics are, will be at room temperature, like in the 20s degrees Celsius. And so it's almost like it doesn't even know it's at the Sun, and it can do this amazing science.
So thanks to Betsy and her team, Parker Solar Probe will be travelling closer to the Sun than anything before, but remain around the same temperature as the average swimming pool. But there's one more detail that made this historic moment extra nerve-wracking for the scientists. The Parker Solar Probe is fully automated, meaning that once the little probe was fired into space, there'd be nothing the scientists could do to control it. Except
there are these little sensors that are the farthest things that stick out behind the heat shield called solar limb sensors. And they're designed that if they light up, the spacecraft knows that it's going off off track a little bit and it needs to right itself. And so it will right itself without any commanding from Earth. We don't have that kind of time to actually right itself. It has to do all that on its own.
So all they could do was hope. On the 12th of August 2018, after over 60 years of planning, Parker Solar Probe finally launched.
Every single member of the Parker Solar Probe team, when we watched the launch, really felt like we were losing a member of the team.
I worked on Parker Solar Probe for 10 years, and at launch, I cried. It was a very emotional moment. And when I see the launch videos, I still get emotional about it.
There was separation anxiety. There's the feeling that this thing that you've worked on for so long is going to leave and not come back. And really, she is the part of the team that's actually doing the exploration.
Parker Solar Probe has had one extra helper out in space though, Venus. Rather than flying in a straight line towards the sun, Parker Solar Probe uses the gravity of Venus as a giant slingshot, catapulting it into closer and closer orbits of the sun.
The first Venus flyby, I think, was the really key one for everybody. Once that maneuver was done, we were go for the sun at that point.
The first solar pass was really emotional but amazing. Of course, when it was actually in the solar pass,
then that's terror.
We can't actually talk to the probe while it's going in. So
until the spacecraft came back out from the other side of the sun and everything was healthy.
When you get that green beacon that everything is looking good after a solar pass, it is just an amazing feeling.
My God, we've done it.
So after having launched Parker towards the sun, on its 8th flyby in April of 2021, Parker Solar Probe finally entered the atmosphere of the sun.
It reminds me of 1969. Every time I see the movie when Neil Armstrong touches the surface of the moon.
That's one small step for man.
That was monumental. In a way, it's a parallel to Parker Solar Probe. When you fly through the solar corona for the very first time, nobody has done that before. It was so exciting and also so humbling to have launched this mission, throw it basically toward the sun, and returns you some data that you never seen the like of it before. It's just eye-opening.
Nora Ruthie has been working on Parker Solar Probe for over 14 years. And in case you're wondering if he still enjoyed it,
it's better by the day.
But the thing that's been exciting Nor more than anything before is the incredible discoveries coming from Parker Solar Probe.
The amount of discoveries, it's way beyond any of us could have imagined. It's just mind-boggling. We are discovering by the day new phenomena in the data that Parker Solar Probe is sending us. Well, the very first data we got from Parker Solar Probe, when we got this data from the fields instrument, we were looking at the magnetic field measurements, and for maybe 15 minutes we were thinking there is something wrong with the instrument. Only to realize that no, the instrument is working perfectly, and actually what we are seeing is physics. It's physics that we have not seen before. And it is these switchbacks, basically the magnetic field will flip over itself, making a rotation of 180 degrees and out again. And it does that in a matter of seconds to minutes, and it is just fascinating. What is really important about these switchbacks is that they carry a lot of energy with them. And that energy will dissipate it into the solar wind in the form of heat and speed. Two of the three goals of the mission is to explain the coronal heating and the acceleration of the solar wind. So the switchbacks could be the smoking gun that actually leads to give us the answer to those questions.
By understanding switchbacks, we could unlock the secrets of solar wind and how it's formed and accelerated towards Earth. Solar wind is not trivial. It reaches speeds of over 1 million miles per hour, travelling way beyond Pluto, and it affects our everyday lives. In 1989, a large solar flare caused the entire grid of Quebec, Canada to fail, leaving them without power for over 12 hours. So think what it could do to a rocket or a satellite. And as well as solving mysteries, Parker Solar Probe is also creating puzzles for Noah and his team to try and solve.
Parker Solar Probe, like any other missions, and answer questions, but by answering a question, it actually poses many more other questions. In a way, that's the essence of exploration. We come to this world as explorer, and we leave it as explorer. On the eve of Christmas of 2024, we will reach the closest approach to the sun ever. That will be 3.8 million miles from the solar surface. It's so close to it. And after that, we do 2 more orbits, and that's the end of the prime mission.
But even after this mission ends, the discoveries made during this epic mission will live on forever in the science and in the scientists.
It is the highlight of my career, and it will be the highlight of my career. Definitely being involved in Parker Solar Probe, it's an honor.
We are really rewriting the textbooks about the sun, and it's amazing to have played a small part in that.
I am incredibly proud to have been part of the Parker Solar Probe mission.
Parker Solar Probe changed me forever. Parker Solar Probe is an enabler in many respects. It emboldened us now to go after very challenging ideas and concepts for future missions. So we are not stopping here.
Jupiter played a crucial role in developing life on Earth. Thank you, Jupiter. We normally just see the very top layer of atmosphere. There are so many secrets of Jupiter contained below these clouds. So I'm currently analyzing data from the Juno spacecraft.
Juno, the spacecraft, has all these magical instruments to see inside of Jupiter. Jupiter is the most extreme environment NASA's ever visited. To send a spacecraft there is a little bit insane. This is one of the largest spacecraft ever made. We had to, build an armored tank to go there.
Jupiter's radiation environment is the most dangerous environment for a spacecraft to go into. It's a region we were very afraid of because no one had ever been there before.
If that doesn't fire just right, you fly right past Jupiter. That's it. You don't go into orbit, you go around the solar system again. By the time you come back to Jupiter, it's decades later.
Almost there. It's a very uncomfortable situation.
Welcome to Jupiter.
We just did the hardest thing NASA's ever done.
What we actually found blew our minds. When you first look at Jupiter, what really catches your eye is the Great Red Spot. It's this gigantic storm in the southern hemisphere of Jupiter. It's larger than the Earth. It has been around for over 200 years, and it's absolutely incredible. Then you begin to look further away and you see these belts and zones moving in different directions on the planet, and everywhere you look, you basically see a storm. And what drives these storms? Well, likely Jupiter is collapsing very, very slowly. This is energy left from its formation, and this energy is released, and it's that energy that churns the atmosphere so violently all the time. This is in contrast to Earth, where our weather is governed by the sun. A lot of tourists go to northern Sweden and Scandinavia to see the northern lights of the Earth. If you really want to show and something that's on all the time, you go to Jupiter and see Jupiter's aurora. It's brighter than all the energy that all the power plants on Earth can produce, and is actually fueled by a volcano. So Jupiter has this moon called Io, and that's fiercely volcanic, spewing out material near Jupiter all the time, about a ton a second of material. This material gets trapped by the magnetic field as energy funnels down, impacting the planet, and that's the aurora we see.
What we find is vortices, kind of like hurricanes. They're all packed together. And we've been watching them now for a year, and they haven't all merged into one. They're packed in this pentagonal pattern. There's actually 6 of them if you count the one in the center. And they just sort of sit there. And this is remarkable. This is really the first time that anyone has seen such a geometric pattern of cyclones on any planet or anywhere. I look at an image like that and I say, wow. The idea that nature can make such a geometrical structure is fascinating.
We've known since the Voyager missions that lightning exists in the clouds of Jupiter. What Juno's found is there's a second form of lightning at Jupiter.
This is the signal from the microwave radiometer, and it's measuring the heat of the planet, and every now and then we get a spike. Bam! It became very clear very soon that this was radio signals from the lightning in Jupiter's atmosphere. Maybe 1,000 times brighter than the lightning on Earth.
The presence of lightning at Jupiter hints at vast amount of water, and Juno's actually confirmed that in the lower part of the atmosphere, 1 out of 400 molecules is a water molecule. That's a lot of water. Does that mean that there's life in Jupiter's atmosphere? Well, ultimately, we don't know. We have this notion of what life is based on our experience here on Earth. Can we translate that to Jupiter? Can there be life forms floating about in the atmosphere? We don't really know. Jupiter is so massive, about 300 times more heavy than the Earth. And with all this gravitational power comes huge responsibilities. Jupiter originally flung water into the inner solar system, creating the conditions for life at Earth. So thank you, Jupiter. It also likely altered the orbit of an asteroid that killed the dinosaurs 65 million years ago. Jupiter's presence, gravitational presence, is absolutely everywhere.
This is the outline of Jupiter, and basically what we're seeing there are just the cloud tops. But what we want to know is what's inside Jupiter.
Before Juno, we believed that Jupiter would have a really small core onto which gas just stuck by gravitational forces. But what Juno has found is actually that Jupiter has got a really big core.
There's something denser. It's probably like 5-10 Earth masses. It's mostly made of rocks at very high pressures and temperatures. So that shows that Jupiter started its life as a rocky, icy world, and that it captured the gas that was around, the hydrogen and helium. And that formed a giant planet that's Jupiter now.
I first became interested in Jupiter when I was at college in Sweden. There was a telescope on the roof, and one night we got to see Jupiter with our own eyes, and it was absolutely extraordinary. A whole different world that I can see right there in the night sky. What would he think about me today? I think he'd be proud, ecstatic.
Today, I am proud to announce that our next New Frontiers mission, Dragonfly.
So Dragonfly.
Go Dragonfly.
We're building a drone the size of a car, and we're going to fly it on a moon.
Dragonfly will explore Saturn's largest moon, Titan.
In 2027, Dragonfly will launch on its 872 million kilometer journey to Titan, the most Earth-like moon we've discovered so far. By the time Dragonfly's baseline mission is over, we'll have flown more than 100 miles, which is almost double the total distance covered by all of the Mars rovers combined. I'm a co-investigator on the Dragonfly mission, and I'm really looking forward to being able to see Titan through Dragonfly's eyes. Titan's been running a big experiment, and it's time for us to go collect the results. Titan is so amazing because in a lot of ways it's very Earth-like. It's the only moon in the solar system that has an atmosphere. It has rain, it has clouds, it has lakes and rivers and sand dunes and mountains. And so, big picture, Titan has all of the things that we think are required for life. We think that there was a period in Earth's history around the time when life originated, when Earth's atmospheric composition was actually probably quite similar to Titan's atmospheric composition today. And so, another one of the questions we have is, what was the chemistry like on the early Earth? How was it related to what's happening on Titan today? And what does that tell us about the origin of life on Earth? Titan is enshrouded in this kind of orangey yellow haze that keeps you from being able to see the surface. And so it was like, okay, we can't see the surface. It's the only moon in the solar system that has an atmosphere. And now we're finding out that there's all of these carbon-containing molecules in the atmosphere that are really, really interesting. And Titan is so interesting that we needed to know more about it. Titan is one of the best, if not the best place in the solar system to fly. If you personally were on Titan and you had some kind of wings attached to your arms for some reason, if you flapped your arms, you would actually be able to fly under your own power. It's that easy. And it's a combination of two things. One thing is that the gravity is pretty low on Titan. It's about 1/7 of the gravity on Earth. So that helps because you don't need as much, energy to get off of the ground. But the other reason why it's so easy to fly on Titan is that the atmosphere is actually more dense than it is at the surface of Earth. So it would be much, much easier, it is much, much easier, I think, to try to figure out a concept to fly on Titan versus trying to send a rover. Dragonfly is not a little backyard drone. It's about the size of a small car. And so that makes it, pretty robust to a lot of things that a backyard drone would not be robust to. Although if it crashes into a tree, as long as we know that it crashed into a tree on Titan, we will be super excited. We will call that a successful mission because we found life on Titan accidentally. We just don't know that much about the surface. And so on the one hand, that's scientifically exciting. And on the other hand, that's a little scary when you're an engineer that's trying to build a spacecraft where you can't, call AAA if something goes wrong. Because of the time delay in light travel between Titan and Earth, Dragonfly is going to have to navigate all on its own. There isn't going to be somebody, sitting on Earth with a joystick flying Dragonfly. There's no GPS at Titan. There's nothing to tell it where it is. Our maps that we have right now are not very good, and so kind of one of these a little bit like, build the plane as you're flying it type things in terms of how we navigate. And basically the way that it's going to be doing that is by taking a really, really lot of images. Where basically every time we fly, we're actually going to fly further than where we want to land so that we can do reconnaissance aerial imaging of the place we think we want to go next. And then we'll turn around and go back to where we had planned to land and land there. Once we tell it, okay, you're going to go do this thing, it will have the whole sequence of what it needs to do. It will be able to make decisions if something goes wrong, and it will decide, okay, this is what I'm doing now, and then, we'll report back and say, look, Mom, I did it, hopefully. But there's definitely a lot of challenges involved in having these big time delays, because we can't control anything in real time. We have all these ideas about the requirements for life. And big picture, we tend to think of the requirements of life as a source of energy, building blocks of life, so like just things that are made out of carbon, and some type of liquid. We think that Titan is a place that it has the possibility of having life. Things that we know we have on Titan are a whole variety of what we call organic molecules. So one of the reasons why we're so excited about carbon when we're thinking about, the search for life and the origin of life is that, selfishly, life on Earth is based on a lot of carbon-containing molecules, and so that's one of the reasons why we're so excited about it. But actually, atomically, it's very interesting. Carbon can make 4 different bonds, whereas when you look at something like oxygen, which can really only make one bond or two bonds. If you think about your kids' Legos, you can only build so many things with a little like one piece Legos, but when you start using the 2 or the 3 or the 4 or whatever, you start to be able to build these really complicated things. And it's the same thing with carbon, because it can make these 4 bonds. It really allows it to make all of these different kinds of molecules, and we think that we see evidence of a lot of that going on in Titan's atmosphere. So we already have a bunch of different simple little Lego structures in the atmosphere, and we just want to know how complicated they got, and whether or not that is kind of similar to the level of complexity that we see on Earth, which might indicate the possibility for the presence of life. And so we want to go and see, with a actual Titan scale laboratory, what has formed from these processes. And so, the more opportunities we have to be able to explore places, the fewer limitations we have on answering our science questions, which is really important.
Right now, the 2 Voyager spacecrafts are hurtling through interstellar space at 35,000 miles an hour. The space is so far away that it took 35 years to get there. And now we need new science to understand it.
I couldn't believe how nature was fooling us.
It made us rethink everything we knew about the shape of our solar system.
I think I discovered that the tail has a croissant shape.
And even where the edge of our solar system actually is.
There was a lot of confusion. Actually, the confusion lasted almost a year.
Even just to understand what Voyager is trying to say requires a very special set of skills.
It's really like a Swiss watchmaker. It needs to be a trained eye to tell me, can I trust this data or not?
What's even more extraordinary is how Voyager, the old spacecraft from 1977 with 64 kilobytes of memory, was able to make this journey at all.
3, 2, 1. We have ignition and we have liftoff.
Both Voyager 1 and Voyager 2 were launched in 1977, and it had to be then, thanks to an extremely rare planetary alignment that happens once every 175 years.
Where we could fly past Jupiter, get a gravity kick and go to Saturn, get a gravity kick and get to Uranus, and another gravity kick and go past Neptune.
Within just 2 years, Voyager 1 had reached Jupiter. Voyager showed us a planet, which looked so serene through a telescope, was actually rocked by hundreds of raging hurricanes, a glowing aurora at the North Pole, and 3 thin rings. Voyager took 33,000 images of Jupiter and its major moons that captured the world.
And we'd get to see these pictures and go, whoa, look at that, what's this, what's going on? It was fantastic.
On a night like tonight, our eyes, our minds, our souls, our blood are moving out through the universe. We're part of history, and that means that we have to replace the old myths with new ones.
Just 1 year later, and Voyager 1 had already sped past Saturn, spying intricate details in the planet's rings. From Earth, scientists could only see 5 or 6 of Saturn's rings. Voyager showed us that there were more than 100.
And I can remember those first pictures as we flew away, looking back at that system and seeing the reflected sunlight in that structured ring system was just so beautiful.
Then the Voyagers parted ways. Voyager 1 headed straight for the edge of our solar system. Voyager 2 took a more scenic route, reaching Uranus in 1986, and eventually Neptune in 1989, showing us yet more outstanding views of the green and blue planets, and spotted geysers on Neptune's large moon, Triton. And that was the main mission, the first human-made object to reach the distant worlds of our solar system. But the Voyagers weren't done yet. They were about to embark on the journey to search for the edge of our solar system. And before they left, there was one last thing to do.
Carl Sagan convinced NASA to turn the cameras towards Earth and take that very famous picture, the pale blue dot.
On that blue dot, that's where everyone you know and everyone you ever heard of and every human being who ever lived out their lives. It's a very small stage in a great cosmic arena.
These images were the last of 67,000 images taken by the 2 Voyager spacecrafts. Their cameras were then turned off to save power as they carried on their journey towards interstellar space, the boundary where our sun's solar wind ends and the rest of our universe begins. Problem was, nobody actually knew where it really was. Scientists thought that sooner or later, the charged particles that create solar wind were going to run out, and Voyager would enter a pristine environment of interstellar space.
We thought that would happen, maybe just beyond Neptune. But no, that didn't happen. Well, we said to NASA, give us a bit more money, another 5 years. Well, this kept happening year after year. NASA, please give us a little bit more money, a little bit longer, we'll be there.
As Voyagers 1 and 2 continued to move out into the outer reaches of the solar system, they remarkably continued to send very faint signals back to Earth.
And this is what makes it so interesting and so fragile. The whole instrumentation of Voyager was designed to visit the outer planets that have very strong magnetic fields. So now you're dealing with a signal that is almost at the noise of the instrument. And because Voyager was not designed for that, it's a miracle fit that all this team is able to go mine the data and pull out the signal and tell us what's going on.
Just 5 instruments were still operating on the spacecraft, and in 2012, more than 35 years since Voyager 1 left Earth, scientists started to see the first signs that they were crossing into interstellar space, through the boundary known as the heliopause.
Think about the heliopause as your walls of your house. This is what separates the environment that is dominated by the solar wind from environment that is dominated from other winds from other stars outside of our bubble, the heliosphere.
The expectation was that there would be a sudden shock, a burst of activity that would make it obvious we'd finally reached this sharp boundary. But the reality was much stranger. All of the detectors on Voyager were seeing particles suddenly appear, and then disappear, then appear and then disappear, and nobody had a clue why. These strange particles seemed to be coming from elsewhere in the galaxy.
Did we cross or not? The data was so confusing.
On one hand, Voyager was still being affected by the sun's magnetic field, but the particles were suggesting we had crossed.
It turns out what really tipped the scale in the team was the radio data.
The data was stored on the spacecraft using a tape recorder. It's so ancient technology, it's extraordinary. But it worked. And the data were gathered and sent back bit by bit.
And 6 months later, we turned to the radio station of Voyager, and guess what we heard?
These plasma waves, converted into sound that we can hear, were the final proof that we had crossed the boundary into interstellar space.
The first human-made object to venture into interstellar space.
Even more extraordinary than crossing the boundary into interstellar space was what the data said about the shape of the solar system.
I was tasked to create a computer model with all the physics that we know to kind of predict this shape of the heliosphere.
It turned out that the solar system's heliosphere is not round like you'd think. It has a tail from whizzing around the galaxy. And more than that,
I was finding that it has a croissant shape, 2 horns with a void in the middle. It was just a shock to realize that something such basic as the shape of our home is completely different.
And all of this was discovered by a small, extremely low-tech probe more than 10 billion miles away. And they're still going. In 2018, NASA's Voyager 2 spacecraft crossed the boundary. Finally, both Voyager spacecrafts, with their 1970s technology, had reached where no human-made object had ever been before: interstellar space.
There's very little material, very empty. Space can be very, very empty.
The environment out there is colder and denser. And of course, it's dark. There's not a lot of light. You're far away from the sun.
Voyager has also discovered that our solar system's impact is much bigger than we thought before.
We would have liked to get to a region where the heliosphere doesn't influence anymore the interstellar medium. What we call a pristine interstellar medium. What we're measuring now is a medium highly disturbed by the sun.
The Voyagers are still sending us ever fainter signals, still teaching us new things about interstellar space, but they're running out of time.
We probably have 2, 3, maybe 4 more years of power to communicate with Voyager.
But there are still so many mysteries left to be solved.
What is the environment outside? What's happening to the nearby stars that are influencing our system and so on?
So one of the beauties of the Voyager mission, that it started as a planetary mission, gave us the first images of our planets, discover volcanoes in the solar system, and then it went to discover our heliosphere, our vast, regions of our solar system, and enter into the galaxy.
Long after their power has gone, the Voyagers will continue to rush away from us, monuments to human endeavour and exploration, heading out towards the stars.
Voyager will continue its little journey in the interstellar space, way past when we maybe as a species will cease to exist, when we might move to a different planet.
It'll keep going and going and going and going and going forever.
This is one of the few places in our solar system where we have a good chance to look for life. There's evidence for a vast subsurface ocean below the icy crust of the Moon. The amount of water that's suspected there is many times more than all the oceans together we have on Earth. On the poles, you're approaching minus 200 degrees Celsius. Icicles that could be several meters high might be present. And if you're very lucky, then you might just spot a plume erupting nearby, like an ice volcano that ejects material from the subsurface to enormous altitudes. On top of that, there's a good chance that there's an energy source at the bottom of the ocean, hydrothermal activity, that can support the emergence of life. That makes Europa outstanding. Europa Clipper is the first mission that goes to the outer solar system that has the exclusive goal to investigate the habitability of the body in the outer solar system. It will launch in October 24 and will arrive at Jupiter in April 2030, so it's 5.5 years for Europa Clipper. Jupiter has like about 70 moons, so the number increases like every year by a bit. But there are 4 moons that stand out, that are the so-called Galilean moons. The innermost is Io, then Europa, then Ganymede, and then Callisto. With the telescopic observations before the arrival of the first spacecraft, you could see that some of these moons are really, really bright. They reflect way more light than a rocky surface would. And so, for example, Europa and also Enceladus, they are one of the brightest objects. And so it was suspected already at that time that the surface might be composed of shiny, reflecting water ice. I mean, after the investigations of the Galileo spacecraft in the late 90s, Europa became a prime target in planetary science all over the solar system. Because with a huge subsurface ocean, with the spectral hydrothermal activity, that became the first place that could be habitable in our solar system besides maybe Mars. That immediately sparked proposals of missions to go back to Jupiter and specifically investigate Europa. I mean, if you are a planetary scientist, probably the most rewarding science goal is to see if a planetary body is habitable or actually inhabited. So Europa Clipper will stay in orbit around Jupiter, and in most of its revolutions, it will have a close flyby at Europa. And the flybys are arranged in a way that it's like a web in the end surrounding the moon, that you have in the end a good overview over almost the entire surface after these 50 flybys. During these close flybys, you get an idea of what is evaporating from the surface of Europa. And from that, of course, you learn about the makeup, the composition of the surface. And this is, of course, specifically true if there's plume and venting activity. That's what I really would put a smile on my face if we could measure plume material that's connected to the subsurface ocean of Europa. The instrument called SUDA, the Surface Dust Analyzer, is the instrument I'm working on. It measures the composition of tiny grains that are surrounding Europa, mostly ice grains. And these grains are knocked off the surface by micrometeoroid impacts. With the SUDA instrument, we can sample these materials, and with that we get an idea about the surface composition. We could constrain what salts were there in the ocean, if there's an alkaline, neutral, or basic environment, if there's hydrothermal activity at the bottom of the ocean, what the organic chemistry inside the ocean has evolved to. Unfortunately, we currently only have one example of a planetary body or a moon where life exists. And so it's very difficult to speculate about the nature of life elsewhere. If we look for signs of life on an icy moon like Europa, it's probably the most straightforward to just look for simple forms of life. If there would be complex civilizations in these subsurface oceans, we probably would have known by now, right? But I know that at least for the life on Earth, the access to oxygen is important to develop complex life compared to simple monocellular life. So this is one of the big science questions that Europa Clipper wants to answer. Has Europa Ocean access to oxygen that is created on the surface? So is material from the surface cycling back down to the ocean? If yes, then oxygen might be available in the ocean, and this opens up the possibility for more complex life. And not just a single cell, but maybe fish-like complex life. Everything between one cell or no life or fish-like life, like complex organisms that might be even intelligent or not, nobody knows. It's really up in the air. I look very much forward to the launch. It will be launched on a Falcon Heavy that was decided only a few months ago. So one of Elon Musk's rockets. And I'm really much looking forward because I never saw a rocket launch in my life. I like to see it. But on the other hand, it'll make me nervous. So that's always a problem. If rockets have a chance, even the safest rockets have a chance of like a 1% or 2% that there's some failure, and then everything was in vain. Because all the development has been done. Most instruments have been crafted twice, that you have a spare. So I really hope that the launch will go well. So I think it's one of the most exciting missions there is, and I'm really glad that I can participate in these endeavors.
It has the biggest volcanic plumes that we know of, with exotic sulfurous compositions, the highest temperature lavas that we've detected. It's as hot as 1800 degrees Kelvin. So Io wins lots of awards for being extreme. Some of us love Io just for its own sake. But it's also a laboratory for understanding other planets, especially the terrestrial planets very early in their history. When they were hotter, they had more heat. This was a time when life first formed, when plate tectonics was getting going. We'd in many ways, studying very early Earth is like studying another planet. Understanding Io might teach us something fundamental. We'd like to understand that type of volcanic eruption without having one happen on Earth today. That would be unfortunate for all of us living here. Io, that's happening today, very high fusion rate volcanism, more active than the most active volcanoes we usually have on Earth. And it changes our whole view of how planets work. For terrestrial planets like the Earth and Moon, Our thinking is that it's kind of like the lifetime of a human being. When you're young, you're energetic and active, and then you get more quiescent and more quiescent, then you die. Boring. Well, these outer planet satellites are much more like the Hindu life cycle, where you can be reborn and go through all sorts of cycles of activity. So very different concept of how planets work. We have no shortage of unanswered questions and mysteries throughout the solar system and beyond. Right. Io is a little bit larger than Earth's moon. It's one of 4 large moons of Jupiter. It's the innermost of the 4 large moons. And 3 of these moons are in a resonance. So every time Ganymede orbits Jupiter once, Europa orbits twice, and Io orbits 4 times. This means that the distance to massive Jupiter is varying, and the whole moon changes its shape, where the surface of the moon rises and sinks as much as 100 meters. In case of Io, every 42 hours. That changing of shape, it's like bending a piece of metal back and forth. It heats it up. So we've proposed the Io Volcano Observer in the Discovery program. That's NASA's low-cost category of planetary mission. But this mission would make 10 close flybys of Io while orbiting Jupiter. It has a suite of instruments, and the tour is designed so that we fly by Io at just the right times and places. In order to measure the tidal gravity signature, we have to have pairs of identical flybys, one when Io is closest to Jupiter and one that's otherwise identical but when Io is furthest from Jupiter. So it sees the same signal except that this difference in range to Jupiter, which changes the shape of Io. That'll tell us really what's going on inside Io. Does it really have a magma ocean? And even if it has a magma ocean, what type of magma ocean? That's really, I think, the most fundamental thing. And we need to get a spacecraft that makes close flybys of Io at a minimum. Landing on Io and orbiting Io would be even better. You have to understand, though, Io is deep within the intense radiation of Jupiter. So Jupiter has a very powerful magnetosphere. So it's a very high radiation environment. It's very tough on electronics. So we're not going to explore Io the way we have Mars with these long-lived rovers on the surface unless we have a revolution in electronics and how to withstand the radiation. So fast flybys is the way around that for now. Get in there close, get a bunch of data, and get out of that radiation as fast as you can. There are volcanic plumes up to several hundred kilometers high, very spectacular, and that some of that material may be directly escape Io, but also that high radiation environment and those energetic particles interact and strip off material. If we're so close that we're flying through a lava fountain, that would obviously be bad for a spacecraft. We hope to fly through the upper parts of plumes where it's mostly gas and very small particles that are not hazardous. Of course, if you make a math error and impact Io, that would not be good unless it was intentional to dispose of the spacecraft at the end of the mission. And that is how we would plan to end it all after the mission is over. It would mean a great deal to me to see this mission go forward. Now, I'm not going to be the one leading the mission at Io. It has to be the next generation. You have to think in terms of multi-generations when you're dealing with the outer solar system, and especially when you have to spend a decade just to get the mission approved. So for me, though, that's all fine. I get it started, and then I enjoy life and enjoy watching others carry on. And I have no doubt that Io will surprise us. It's a very surprising place, and it's surprised every mission that's ever looked at it. The conventional thinking is that there's no way there's life on Io. It's too hot. Well, it's only hot over 1% of the surface. There are certainly places with better temperatures. It's also thought that there's no water. Well, we haven't detected water, but we didn't think there was water on the moon either for a long time until we got better measurements, so we might be surprised about that. And also, what kind of life are we talking about? The only thing we know how to talk about is life as we know it, which is carbon and water-based life. So if it's some other kind of life, then who knows? All bets are off. So it's the surprises that will be the most fun and the most significant.
It was really a wow moment. There was liquid water elsewhere in the solar system. We had been right. You have all of the ingredients that you need, that we know of, to develop life as we know it.
We have cleared the tower, and the Cassini spacecraft is on its way to Saturn.
So these sort of hard cases, these James Bond-looking cases, are used to transport the flight hardware. This is one of the magnetometer sensors that I worked on, and it will have been integrated onto the boom that came out from the side of the spacecraft.
And here's part of the magnetometer instrument, and here's the other half of the magnetometer instrument. This is a quarter-sized model, so this is a quarter-sized me. I'd like to be this weight, not this height.
She was one of the best things about the Cassini mission, because I spoke to her on the phone every couple of days for years and years and years. So a gas giant like Saturn is incredibly mysterious.
Saturn just captivates people because it looks so supernatural. It engenders the immediate feeling that it can't possibly be real.
It has no solid surface, and it has rings around it, and we don't necessarily know where those rings came from or how old they are.
These, as you can see, are spiky shadows that are created by these features here that are sticking up 2.5 miles.
Having the perspective of Cassini to be able to see that was one of the most extraordinary things, I think, about the images that came back.
It was just extraordinary. It was out of science fiction.
Some of the most amazing discoveries that Cassini made were about Saturn's moons. The first flyby of Enceladus was not terribly close, but something funny was happening in the magnetometer data.
Okay, so put it into slideshow.
My boss came to the team and said,
you can see there's a little pimple in the data, just over there.
This looks intriguing. This is not what we expect. We expect on a rocky moon for the magnetic field to drape over it, a bit like a nice peaceful curtain draping over a window that's not moving. And instead, it looks like there's some sort of breeze gently fluttering that curtain.
And what we were able to do is calculate what ions were generating those waves, and it was water group ions.
So Michelle decided, after discussions with all of us, that she would go to the Jet Propulsion Lab and she would propose moving the next flyby of Enceladus, which wasn't for some time to come, to much sooner. And this was a huge risk for her.
We knew for us to be able to have a chance of really seeing what was going on at Enceladus, we needed to get closer.
The principal investigator of the magnetometer, God bless her, she went into action and convinced the project to take the spacecraft close to the South Pole so we could all get a better look.
And I must confess, I didn't sleep for 2 or 3 nights before that close flyby, because if we hadn't seen anything, no one would ever have believed anything I said again. So, but what we found was spectacular.
This image made me nearly fall off my chair, because here we see dozens of jets, big and small, coming off the South Polar region.
It was fantastic.
It was really a wow sort of a moment. There was liquid water elsewhere in the solar system other than the Earth. Enceladus, tiny rocky moon of Saturn, is geologically active. A stable liquid environment, organic material, and contact with rock, you have all of the ingredients that you need, that we know of, to develop life as we know it.
I love this picture, and it's about as much meaning as you can get out of the Cassini mission, because we know that that moon has an ocean in it that could harbor life.
One of the mysteries of Saturn originally was the source of the rings, and it turns out that Enceladus's geysers feed the very faint but very wide E-ring. It shouldn't be surprising that we found such interesting geological activity on a planet with 82 moons. Ironically, all these wonderful discoveries that we made meant you run out of fuel. It was on 1%, it had an empty tank, so we had to crash it into the planet and let it go.
This is the start of the end of the mission. We're running out of fuel, and we're going to make sure we go out with as much great science as we can.
We want to see how much of the atmosphere we can see before we lose the signal, before it can't fight the atmosphere anymore and it goes off point.
These last grand finale orbits where Cassini dove between the rings and the planet, they were never foreseen in the original mission planning. Actually getting to do that was really remarkable. Take these kind of dangerous dives between the rings and the planet to see what that space was like. Actually, with the spacecraft physically being there, was really remarkable.
In some ways, I just want it to be over now. You know, you're sort of waiting for it to end, and it's really weird.
Quite a lot of us were gathered round, tensely waiting for the data to come back. We were relying on the commands that we had written and we had sent to the spacecraft to have worked properly, and for the spacecraft to continue to be able to talk to us right up to the very last minute.
I can confirm science playback is locked.
And then it'll go away. We'll lose the signal, and that'll be end of mission.
Cross for 0 time.
So that would be the end of the spacecraft. Project manager off the net.
It doesn't feel a long way away, actually, because every time I watch it, I am immediately there again. So that I guess says something about the impact that the end of mission had.
That was a great spacecraft. It did exactly what we asked it to do, all the way to the end.
When you have checked on a spacecraft every day for more than a decade, and then suddenly it's not there, it really is a wrench. It's a blow, and you feel sadness and a certain amount of grief.
Godspeed, think it and release it.
Is the signal real? If the signal is real, we still have to be able to explain what or who is making it. I've dedicated my entire career to finding life beyond our Earth, and lately I've been trying to find it on Venus, the planet next door.
Oh wow, life on Venus. That just blew me away.
Venus, it is an absolute hell. The temperatures on the surface average about 470 Celsius, which is hot enough to melt lead. Air pressure on the surface is what it would feel like to be about a mile under the ocean. Because the clouds of sulfuric acid are so dense with haze, Venus became a desolate hellscape. The Venera missions were an extraordinary program. Several of the Veneras didn't even attempt to land. One of them lasted 127 minutes and provided a lot of data. Some tried to take pictures, but the lens caps wouldn't come out, and by the time we got to 7, 8, 9, 10, 11, 12 Veneer emissions, we had managed to get to the surface of Venus, take measurements and be sure of its intense temperatures and pressures, and also the hurricane level winds that were passing in the atmosphere.
When they eventually got the correct sort of radar going through the clouds and seeing what was going on, and then it got really exciting. Then we thought, this is a planet with a lot of volcanoes on it, and even more fascinating, volcanoes unlike any we see on the Earth.
These volcanoes had been partly responsible for spewing out gases that led to Venus becoming the fiery hell it is now. But recent data shows there may still be life left in them yet.
They found that Venus had hotspots within it, something active on Venus. That really is quite exciting to actually see these.
We do know life is very resourceful, and there is one place on Venus that could host life. If there is alien life in the clouds of Venus or anywhere else beyond the Earth, we have very little hope of ever actually seeing them. But we can look for the gases that life produces, and that is what I've dedicated my entire career to do. My specialty is looking for a gas called phosphine. It was just here, you know? I was actually trying to find my phosphine molecule. Okay, well, we lost phosphine, which actually is very fitting. On Earth, phosphine, it's produced by life that doesn't care for oxygen. So I thought maybe we could find phosphine on other planets that are oxygen poor, and there it would be a very robust sign of life. An astronomer from Cardiff named Jane Greaves reached out to me saying,
"Oh wow, perhaps there really are these floating microbes."
They needed some help interpreting a potential signal from Venus obtained with the ALMA telescope that seemed to indicate there was a sign of phosphine in the clouds of Venus.
When you go really high up, so about 50 kilometers up, the pressure in the clouds is like it is at the surface of the Earth, and the temperature is actually like 20 or 30 centigrade, so it's really quite habitable.
Jane and the rest of our team used 2 telescopes, many months apart and in completely different parts of the world, to look at the atmosphere of Venus. And these 2 independent observations agreed with one another.
So that was January 2019 when I was reasonably sure, and that's June of 2019. I was like, here it is again.
I at first did not believe it, but there was a small part of me that thought my whole career had been for something.
It's really obvious there's something there, so that kind of blew me away.
Maybe all the work I had done saying that phosphine was a sign of life was just going to pay out right now.
Astronomers have announced they found what could be evidence of life elsewhere, and not on Mars, but on the much more inhospitable Venus.
There's something seriously weird going on there. Perhaps this is life. And that just blew me away. It was so exciting.
So you can see that really they look very like each other. So it was a robust result. 2 telescopes, nothing to do with each other, saw the same thing.
My second instinct that kicked in quite quickly was, is the signal real? If it is it for sure phosphine, or could there be another molecule mimicking it? And if it is real and it is phosphine, was I right in saying that only life could produce it?
Well, there are 2 ways that it could possibly be life. One is there's just a completely different biochemistry there. It's radically different from anything we imagine on Earth. The other way, that in principle, a more water-loving life, a bit more like the biochemistry you see on Earth, could hide itself away inside a protective shell of some sort, inside the sulfuric acid droplets.
There's questions on whether even the signal is real. If the signal is real, there are questions on whether it is phosphine or potentially other molecules that can mimic the same signal, like sulfur dioxide. If the signal is real and it is phosphine, we still have to be able to explain what or who is making it. And only then could we consider that we have found life. We're all just trying to figure out the truth. And I would love for there to be phosphine, but primarily I would love to know what's happening in the clouds of Venus, phosphine or no phosphine. And the rest of the community is doing the same thing.
really hoping somebody will come in and say we could start to plan for a space mission. A fly through the atmosphere would be super exciting, and given they managed to get a lander to the surface and signals out in 1985, that's got to be possible, right?
We are only just now beginning to be able to even interpret the signals from places that could host life. It's a really exciting time to be discovering potentially the first one of those signs in the planet next door. But there will be many, many more to come.
This tiny little moon, 500 kilometers in diameter, has proved that it can surprise everybody. Water vapor plumes with organic material coming out of this tiny little moon, who would have thought? I get asked whether Enceladus is my favourite moon, and at the moment it is, partly based on the observations that my team made and the discovery that we made at Enceladus. So the Cassini mission was the first spacecraft mission to orbit around Saturn and its moons. It was also the first mission to taste what was in an extraterrestrial ocean. The mission kept being extended and extended, and so in the end the mission lasted for 13 years. The discoveries were pretty radical. We were flabbergasted, to be frank. I think for me the most surprising discovery that was made was this water vapor plume at Enceladus, which we then followed up with discoveries about a liquid water ocean, under the surface a heat source, organic material. I've now given away all the secrets. My team and I changed the course of the mission because this was a team effort. So we had 3 flybys of Enceladus, and 2 of these flybys were quite distant flybys. In the data that my instrument took, so data from the magnetic field in the environment of Enceladus, we saw some strange signatures that we weren't expecting to see. And what those signatures were telling us was almost as if Enceladus was a bigger obstacle, a bigger body than it looked. We thought maybe we hadn't got the trajectory of the spacecraft back properly, so maybe we were seeing an artifact in the data. But the fact that we saw it on 2 separate flybys meant that we said, okay, we thought we were seeing something. So I actually traveled out to the Jet Propulsion Lab, and I was planning to make a presentation to the project, because what I wanted to do was I wanted to persuade them that we thought we were seeing this really strange atmospheric signature, and that it would be really good to go close on the 3rd flyby. And I was really nervous, because if the flyby changed, that meant all of the plans that we had made for the last 6.5 years would have to be changed, and some instruments would not take the data that they'd planned to. But the possibility that we would discover this water vapor atmosphere at Enceladus was exciting enough that the majority of people decided it was worth a go. It was extremely nerve-wracking waiting for that 3rd flyby. So, I'd essentially put my and my team's reputation on the line. And so I must confess, the 2 or 3 nights before the flyby, I didn't sleep very well. I tossed and turned a lot. Because if they hadn't found anything, no one would ever have believed anything I said again. Every once in a while you have to be brave and you have to say that you think you're seeing something, but luckily they found something. When we had that 3rd flyby, what we found was, instead of there being an atmosphere covering the entire surface, there was simply an outgassing of water vapor from the South Pole. In addition to that, because we went so close, all of the other instruments were able to take fantastic data sets as well. And what we found is there were cracks at the South Pole through which this water vapor was escaping. There was an internal heat source. There was organic material. And so that meant we had 3 of the 4 things for potential habitability to form. You need a heat source, you need liquid water, you need organic material, and then you need those first 3 things to be stable enough over a long enough period of time that something can actually happen. So that's when there was a real focus on Enceladus for potentially being a place where life or habitability might have been there in the past or might be able to form in the future. The coming together of all of the Enceladus data and the discoveries that were made underpins what I think is one of the most important discoveries that has been made in planetary science in the last 30 years. And that is that you don't need to look close to the sun to find liquid water. You can be quite far from the sun, but you can find liquid water. It's just not on the surface, it's underneath the surface. And so that's been almost been a sea change in planetary science. We now have a much better understanding about Enceladus and its internal structure. So we have a global liquid water ocean underneath the surface of Enceladus, and the surface is made up mainly of water ice. Biggest unanswered questions for Enceladus are, why is there only a water vapor plume at the South Pole? We still don't quite understand why there's a heat source, because the fact remains that it was formed billions of years ago. Because it's so small, it should have cooled down. And so we think it might be linked to its orbit around Saturn. So if the orbit around the moon is not completely circular, then on some parts of the orbit it's closer to the planet than on others. And when that happens, tidal forces keep the interior warm. I think Enceladus will always be memorable for me, because in some ways it was my way of becoming confident in my ability to persuade people, but also confident in my team and what we were able to do with the data. That's probably why it's my favorite moon. Depending on what we discover at Ganymede, it might move slightly down my list. For me, it was almost a coming of age for my team, but also for the instrument. You know, people say to me, why do you explore planets? And for me, we are explorers. Humankind have always been explorers. When we didn't know much about the Earth, people would take ships and go to what some people said was the edge of the Earth, and they were scared they're going to fall off. For me, exploring planets is part of that exploration. It's what we do. My first view of Saturn, actually, was through a telescope that my dad built. I saw Saturn and its rings. Didn't see any of the moons because Saturn is so far away, but we were able to see the rings clearly, and we also saw Jupiter and some of its moons as well. So I never thought back when I was a child that I'd end up doing what I do today. I will never forget Enceladus. In planetary science, it will always be an important thing, and it will be an example that people refer to in the future as well.
The question we all want to know is, are we alone? And now we have eyes on the ground. Perseverance is ready to answer that question for us.
Touchdown confirmed. Perseverance safely.
For the last 4 years, I've been recreating the surface of Mars in my lab at the University of Oxford. What I've most been interested in is whether I could recreate lakes and other liquid water environments that might have existed on the surface of Mars about 3.5 billion years ago. Where it gets really interesting is that now NASA has landed a rover, the Perseverance rover, right in a crater that might have once hosted a lake. Although there's no water on the surface of Mars today, there is inescapable evidence that it was once present. When you look at it from space, you'll see certain features that jump out at you as being quite similar to those we have on Earth. You'll see sweeping valleys that look like they were carved from liquid water.
These are actually pebbles that are a few centimeters in diameter. What you can see when you look at the pebble outlines is that they have rounded shapes. So they've been basically rounded during a transport process. And they're too large to have been moved and rounded by wind processes. And so the only way we can actually get this rounding is by water flow.
You'll see gigantic canyons. This one here is the Valles Marineris. And this thing would stretch from Los Angeles to New York. This thing is truly colossal.
And I remember when this image first came up and we were all huddled around a giant screen looking at this. It actually took us a while to really hit home. Oh gosh, actually this is the first evidence from on the ground of water flow on Mars.
We see great big ice caps at the poles, much like we do on Earth as well. We see signs from space that are immediately recognizable as great big channels, enormous floodplains, the largest in the solar system, that would have excoriated their way across plains as large as the continent of North America. We see chemical signatures, we see minerals that have water locked in their structures that could have only formed when that water was freely available. And we also see both of these coming together in the form of certain features that we know from studying them on Earth only form where there's bodies of water. Where Perseverance is sat is a crater called Jezero, and why Jezero crater was selected is that it combines these two key indicators of water in one site. And how deltas form is where you have a river flowing across the surface of a planet, and in its water it's containing all kinds of churned up sediments. And then as soon as that river reaches an open body of water, like a lake or an ocean, it dumps all of that sediment load. Why the Perseverance mission is so exciting to me is that for the past 4 years, it was those carbonates that are found in its delta that I was trying to recreate in my lab. Perseverance has been in the making for a very long time, and it's a roving scientific suite of instruments. It's a moving laboratory, and it's absolutely incredible the things it can do. So to finally get to hear the sounds of grains of sand being turned over, and the sounds of that very thin atmosphere being blustered around in this crater, it's absolutely incredible. And the first times I saw the pictures from the surface, it was like being in Star Wars and learning about whole new places. I couldn't believe it, and here 5-6 years later I am with my PhD on the surface of Mars. I feel very, very fortunate.
Altimeter data confirm that Ingenuity has performed its first flight of a powered aircraft to another planet.
What's incredible about the little Ingenuity craft is that this is the first time anything has been airborne on another planet at all, not just Mars.
So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible!
The idea is that it might be able to scout ahead to places of interest for future astronauts and look for any hazards. Perseverance has 4 main scientific goals. First is to search for habitable conditions. The second is it's interested in searching for biosignatures. The third mission goal is to harvest and then cache together samples of interest to return to Earth. The absolute dream is to one day have a sample of Martian soil returned from Jezero crater from those carbonates that you can see from orbit, and to compare that to the kinds of crystals that I was forming in my lab, and just see how similar are they, what do they look like. And the final goal of the Perseverance mission is to prepare for humans to come and live there one day. People who are fit, people who are top in their fields, people who are experts, people who have a spirit of adventure. But I would say most critically, you need people who have the right temperament.
Think about a mission to Mars. What is it? Is it outdoor stuff or is it confinement? And then I see somebody that says, I have a stamp collection, I do a lot of reading, I enjoy watching movies, and I'm thinking, that might be good for confinement.
Artemis is a key step in getting humans to Mars. Right now, launching humans from Earth is extremely expensive because we're just so heavy getting off this gigantic rock. Instead, if we can have a base set up on the moon, we can have supplies ready to go from there, manufactured on the moon, that can then be launched straight to Mars. And so this makes it cheaper and easier to be launching things not just to Mars, but perhaps around the solar system as well. Once you've got to Mars, there are a whole host of problems that you wouldn't even think about based on life on Earth.
So you need something to protect you from essentially exploding, or at least having your skin all stretched out and the blood boiling and getting the bends, things like that. The way spacesuits are designed now, they're mostly pressurized spacecraft. Essentially, they're almost like a mini spaceship.
Things like, how do you maintain water? How do you recycle your water supply? How do you recycle waste?
Here we are at the throne. Number 2, right here. It's pretty small, so you have to have pretty good aim.
How do you keep making the best of everything you've got without throwing things away? And they're all problems that we're going to have to overcome if we're ever going to be a spacefaring interplanetary species. A I've had a very long time to think about whether I would go to Mars, and so I'm not being flippant when I say yes, absolutely. Would absolutely love to go. It would be the most fabulous adventure. There'd be so much to do and explore and so many questions, endless questions. So yes, absolutely.
We're used to seeing NASA fire up its rockets and launch billions of dollars of equipment into space. But what happens when it messes up?
The Hubble Space Telescope project has suffered yet another setback.
And how do you fix a $1 billion mistake up in space?
I did not have a line item that says NASA put wrong mirror in telescope.
With engineers needing to fix it not once, but twice.
So the summer 2021 event was a pretty intense anomaly.
This is the story of how the Hubble Space Telescope nearly destroyed NASA's reputation, and the retired engineer that helped bring the telescope back from the brink both times.
When I received the call, I was honored that they would think of me to try and help them resolve this.
This is electrical engineer Ron Barish.
I started working on Hubble in 1987, approximately 2 years before launch.
Hubble was one of the most ambitious space projects the world had ever seen. NASA had spent hundreds of millions designing a massive mirror in the telescope to get the sharpest pictures of the universe ever seen. Expectations were high. It promised to catapult space science into a radical new era, and all eyes were on it.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
It was very exciting to watch the launch. When it was turned on in orbit, very exciting.
NASA was quick to champion it as the greatest advance in astronomy since Galileo. But then disaster struck.
The Hubble Space Telescope project has suffered yet another setback. Engineers have discovered that the giant telescope has a warped mirror, which means the images sent back to NASA are distorted. The pictures are little better than those from ground-based telescopes.
We found out that there was distortion in the image. Well, the images I saw were blurry. They called it spherical aberration.
When light enters the telescope, it's reflected first by a large 8-foot mirror onto a smaller secondary mirror, which concentrates the light onto the cameras. If either mirror is slightly out of true, the picture becomes distorted.
And that's exactly what had happened. The mirror hadn't been tested with the rest of Hubble. Had it been tested, the scientists will have seen that the mirror was ground incorrectly by just 1/50th of a human hair. Tiny, but enough to ruin everything.
Everyone on the project was very disappointed, and it was an embarrassment that we had spent so much time on the program and that there was a significant flaw. The news was not very kind to the project.
For the American taxpayer, they're not going to be happy.
Well, look, you launched this $2 billion white elephant. What are you going to do?
And the bad news kept coming, as NASA's reputation received blow after blow after blow. But despite the setback, there were still some that had hope for Hubble.
So do not write off the Hubble telescope. It merely means it's not going to be quite so good as expected until the repairs are carried out.
Replacing the mirror wasn't practical. So instead, Ron and the rest of the team created an instrument called CoStar, which would act almost like a pair of glasses, redirecting the light to account for the flaw in the mirror.
My job was to provide an electronics interface box called the Remote Interface Unit, CoStar.
3 years after Hubble's embarrassing start, they finally had the parts needed to fix the broken Hubble Space Telescope. All that was needed now was a team of astronauts bold enough and daring enough to attempt a mission of this magnitude.
There weren't very many of us in the office at that time who had done spacewalks, and so that's how I got kind of a quick turnaround from one flight to the next.
You know, in all the failures, the hundreds and hundreds of failures I came up with that I had to accommodate, I did not have a line item that says NASA put wrong mirror in telescope.
Catherine Thornton and Story Musgrave were 2 of the astronauts that were selected for the mission, and in 1993, they set off. The world held its breath as the astronauts carried out 5 back-to-back spacewalks in an attempt to bring Hubble back from the brink.
The first spacewalk on Hubble, to the dance. When the music starts, what you gonna do? Well, you got a power tool and you unbolt the thing, you undo the connection, zip, zip, stick it in the box. Hang it over there, get the new one out. Slide the new one in. It's fingertips, baby, fingertips.
That's what's so awesome about Hubble. It's almost like plug and play. We installed CoStar. We installed a coprocessor on the computer to give it more memory, added a new magnetometer, and other cats and dogs, as we called it.
It is easy. You've got to make it easy.
Around the world, astronomers anxiously awaited the first pictures from Hubble's new camera. On the 18th of December, 1993, the results came in.
Hey!
Right there!
Oh!
When an image hit the monitor, oh, God, the whole room, everyone screamed. It just got it fixed.
Okay. That is better than any decompletion you've ever seen.
Those are actually stars.
I think you got it.
Yeah.
Yep.
Sir. It may be a little premature, but I'll shake your hand.
When the images first came back and I saw them, made me feel proud that I was part of that mission and that we had brought the telescope back to what it was supposed to be. As a matter of fact, my understanding is the images were clearer than what they had ever expected.
To the relief of Ron, NASA, and the entire world, Hubble was finally fixed, and it immediately began to deliver on its original promise, allowing us to see the universe in ways we could previously only dream about. Hubble was only supposed to last 15 years. Instead, it continued to make groundbreaking discoveries for more than 30. But then in 2021, it suddenly shut down. And the team at NASA once again had to fight for Hubble's survival.
So the summer 2021 event was a pretty intense anomaly, probably one of the more dramatic ones that we've had.
Nzinga Toll is the anomaly response manager for Hubble, and it was her job to figure out why Hubble's computer had shut down and ultimately find a way to get it back up and running. But that was far easier said than done. So Nzinga had to think outside the box.
After the first few days, and it wasn't immediately apparent that we could get a path forward to resume science, we knew we'd have to pull in a lot more folks.
With Hubble still showing no signs of life, Nzinga knew she needed some very niche expertise to try and help fix Hubble. So she called upon Hubble's original architects to come back and get stuck in.
When I received the call, I was honored that they would think of me to try and help them resolve this. Anytime you work on a system like this, it's part of you. It's if there's ever a problem with a spacecraft in orbit, everyone jumps in and works on it, even if you're retired. A lot of people were concerned that we would not be able to fix the Hubble. It was very stressful. The last thing I wanted was to have the system that I spent 18 years of my life on to be the cause of the end of the mission. And so I was under a lot of stress.
But undeterred by the challenge, the team set to work to identify what went wrong and get Hubble back online.
The telescope was down for approximately 4 weeks.
I think the first couple of weeks was probably the most frustrating and the most anxiety producing.
We put together what's known as a fishbone diagram. Everything that could possibly cause the problem was written down, and we eliminated them one by one until we zeroed in on the exact cause. It was amazing how everything came back to me.
On July 15th, Nzinga and her team successfully powered up the backup computer on board Hubble. And over the next few days, the team gradually brought the science instruments back online.
Once we realized that we had solved the problem and the telescope was back up and running, it was quite a relief.
Mainly relief. Mainly a lot of relief.
How did it feel compared to 93?
In my case, it was even better. This was my system that had stopped, that had halted the telescope, and to be able to get it back up and running was very proud. I was very proud when, after the first servicing mission, that we got the telescope up and running, but this was more personal. If another problem comes up, I'd be very proud to work with this team again to resolve any future issues.
It would be an honor and a privilege for me to be called back to support Hubble at any point in time. I will always be a Hubble hugger.
I'm NASA astronaut Jessica Meir. I may be one of the first people to return to the moon. The Artemis mission has this stated goal of sending the first woman and the first person of color to the surface of the moon. It will have been over 50 years since humans have set foot there. We aren't just going to go there once and then come back, or go there a few times like in the Apollo missions and then come back. We're going to keep this presence going with a gateway program that will be an outpost in orbit around the moon. Think of it kind of like a little mini space station with subsequent missions of landings on the moon, and then eventually using all of that time and knowledge in those lunar missions as a springboard to go even further and go to Mars. My mom tells me I first started saying I wanted to be an astronaut when I was 5 years old, so it actually was quite difficult to believe when it came true in 2013 when the phone rang and I was given the option to come here to NASA to be an astronaut. It's almost felt surreal.
Copy, Jessica's egressing, 10 seconds to a 20-second handover.
Coming out of the hatch for your first spacewalk is a moment that I don't think anyone ever forgets. My first spacewalk happened to be only a few weeks after I arrived on the space station. So at that point, I was still learning how to move and navigate myself around on the space station. That day, I was with my colleague and friend, Christina Cook. She was in the same class of astronauts as me, so we really are like astronaut siblings. She's like my space sister. We were ready to go out of the hatch that day for the first all-female spacewalk. Of course, there had been other women that had done spacewalks before us. We were the 14th and 15th women to do so, but this was the first time that two women together were going to embark on a spacewalk. So there I am, and I'm looking down at my feet, dangling below the hatch, and then there is nothing else between this Earth spinning below and my feet. And that was just the most profound moment. I was just in awe and so excited. Just us up there. We're floating the whole time, going around our planet every 90 minutes. It was still, even though I was living it, even though I understood the science behind why I was there, it was still difficult to believe that it was actually happening. So it was really only after the spacewalk ended that I started thinking more about what it meant. And it was interesting because in the beginning I thought, why does it matter? Why is there so much attention being drawn to this first all-female spacewalk? It just happens to be the fact that right now there are two women going out the door. We're just as qualified as everybody else up here, and so it's just a matter of time that this would happen. But then when I started thinking about it differently, so many people tuned in to watch that spacewalk, and so many people started giving us this feedback about how inspiring it was for them and how much it meant for them. And that really took me a little bit by surprise. And I also started thinking more about the generations that came before us. So Christina and I, both of us, when we look at this now, we don't think about it as our personal achievement. We had that opportunity because of the generations of women and other minorities that had worked so hard, that had truly pushed the envelope and broken those glass ceilings to allow us to be where we were. So now, when we look toward the future and we look at the Artemis program, this administration has set forth the goal that we will be sending the first woman and the first person of color to the surface of the moon. Of course, I would be absolutely thrilled to be that person, to be one of these first people returning to the moon. And to me, it would represent so much. I know somebody asked me once what I would say, what would be those first words, like we have those famous first words from the Apollo mission. And that is something I would have to put a lot of thought into. I think to me it would be a little bit like how I described that first all-female spacewalk. it wouldn't be about my achievement. It would be about the achievement of everybody on this NASA team that got there. And it wouldn't even only be limited to that. Really, that next person that goes to the moon is a representative of all of humanity. So a lot of people ask us, why haven't we been back to the moon? If we did this 50 years ago, why is it so difficult? Why haven't we been doing it? There's nothing easy about going to the moon. What we accomplished in the 60s was extraordinary. We are due to go back to the moon for so many reasons. The first is simply for exploration. It is an inherent characteristic inside us as humans to explore, to want to look around the corner, to go further, to ask those questions and just quench that curiosity that we have. Secondly, though, and equally as important, is for scientific reasons. If we look back at the Apollo missions, we learned so much about our solar system, about the formation of our planet and of the moon, and I know that that will be true as well for the Artemis missions. For example, we'll be targeting the South Pole because at that area, we know that there is much more frozen water. So by going to that spot, we can study and understand that water, that ice, that frozen water will help us understand more about the moon, about our solar system, and it will also be a resource. We can use oxygen in the soil, we can use that frozen water in the surface, we can use that to make fuel, to make resources for further exploration. So that would be that next step. Take what we learn in the proving ground around the moon and now use that to get to Mars, where we need to be autonomous. We need to think about things like sustainable food systems. We won't even be able to necessarily carry all the food and water that we need up there. So maybe we want to bring some things that we can grow. Everything that we learn in these early Artemis missions to the moon will apply then on to Mars. Fairly soon, we will be launching that Artemis 1 test mission, and that mission will be about 3 weeks. It will go all the way out to the moon and beyond it, and we will test out all of those systems of the Orion spacecraft and that launch system. The next mission, the Artemis 2 mission, would have crew members on it. So that will be the first mission that has astronauts going out to the moon. They won't yet land on the surface of the moon, but they will go out again further than the moon. They will be in orbit around the moon before they come back here. So that will be another vital step in making sure we have everything ready and we're prepared for those later missions, which will then land on the surface of the moon. We'll also have the Gateway, which will be in orbit around the moon. So think of it kind of like a little mini space station. Instead of being around the Earth, though, it'll be there proximal to the moon. And then we can use that to go back and forth. We can keep people on board the Gateway, and then we can have regular excursions down to the surface of the moon. We can use that as a test bed for other hardware and technology and experiments. And then we can eventually use that as a stepping stone to getting to Mars. To me, the moon represents this spirit of exploration that I think has driven humans from the beginning of evolution of our species, and also me personally. The stars, the Milky Way, the moon were so bright in our view, and I think that's something that really shaped part of my childhood, letting that natural scientific curiosity, that spirit of exploration, extend not only from what was in front of me on the ground, but also to what was lying up there above. And of course, the moon is this incredibly prominent object and something that I think we're all drawn to. It makes me so optimistic now to know that it is a national priority again. We have laid out this foundation to get back to the moon, so we will return.
You waited years for this! I waited years!
This was almost the perfect day. Almost.
Rosetta was and is a unique space mission.
It's a travel not just in space, it's also a travel back in time to the very early days of the solar system.
This is the story of the epic, ambitious mission to land a spacecraft on a comet hurtling through space. Nothing like it had ever been attempted before or since.
Rosetta completely transformed our view of comets.
It was a mission 25 years in the making that all came down to a few frantic hours.
Philae was not anchored.
It bounced We don't know where it is.
But let's go back a bit to 2004. The Rosetta spacecraft, with its little Philae lander tucked away inside, is about to launch.
3, 2, unité. Top, à l'image EAP, décollage.
Well, the actual launch took place on 2nd of March in 2004.
The first part of the mission was just to catch up with the mysterious comet, known as 67P. That took 10 years, during which time everything on board Rosetta was powered down, only to be woken up as it neared the comet.
It was quite a nervous time when Rosetta was coming out of hibernation.
Because if it didn't wake up, that was curtains, really.
€1 billion of kit out in space, and if it didn't call home at the expected time, there was very little that could be done about it.
And then it got this signal, wake up Rosetta, and it's just like, hasn't woken up. All right, send the signal again. Switch it off and switch it on again. Ta-da! It's woken up, which was just so much of a relief.
Hurdle 1 out the way.
When Rosetta woke up, that was really the point where everybody got excited again. We had no idea how the comet would look like.
We don't know what shape it is. It's probably spherical-ish.
We didn't immediately see the high quality images. We saw better and better ones the closer and closer Rosetta came.
Then, wow, what shape is that?
The shape is not potato-shaped as we expected, not roundish. It's
The comet has this kind of rubber duck shape.
It's like one of those yellow plastic ducks.
And that made hurdle 2 that extra bit harder, landing Philae safely on top of it.
There was no area on this comet which is nice and smooth as we have hoped for. The terrain was rough everywhere. So there was a risk, but that also made it fascinating and interesting.
Philae was equipped with little harpoons to fire off to help it cling to the comet once it made contact. And the landing site had to be meticulously chosen to allow Philae to recharge its solar batteries in the glow of the sun. The stakes were huge. This was a lifetime's work for most of the scientists on the Rosetta mission. The team already knew there may be a problem with the thrusters that were supposed to slow down Philae's approach, but the time had come to deploy Philae. And on the 12th of November 2014, off it went.
One could see the Philae lander as it moves away from the main spacecraft, getting smaller and smaller with the landing gear successfully deployed. I found this already very emotional to see the baby go after 10 years attached to the spacecraft. You now see it in freedom on its way the last 22 kilometers to the surface of the comet. And then Philae was free falling for almost exactly 7 hours to the surface of the comet.
Everybody was, jittery and just waiting and waiting and waiting for the signal to say it had landed.
And then
I just went absolutely, hey, it's landed, I'm so excited, it's landed. It was just the tension that had wound up and the release of that tension and the relief.
We've waited years for this.
I waited years. I'm just so excited. I'm gonna cry. I'm sorry. It's fantastic.
And of course, everywhere in the world, in the control rooms, in the scientific teams, people started to open the champagne and started to celebrate.
It landed. It was fantastic. It was wonderful. Everybody was really, really, really happy.
In the control room, we thought, yeah, great, we are landed. We have the touchdown signal.
But the mood in the control room was suddenly very different. Something wasn't quite right.
Within a few minutes, we realized that although we have landed and although we still got radio contact, which was positive, we did not anchor and the lander was moving again.
And then the principal investigators came out of their little cocoon and Ian came up to me and he gave me a big hug and I gave him a big hug and I said, it's fantastic, isn't it? It's really great, you must be so proud and pleased. And he said, no, it has gone wrong. It bounced we don't know where it is. I said, what do you mean? He said, well, it hasn't been announced yet, but it will be announced in a minute that actually Philae did land, but the harpoon didn't anchor it, and the little crampons on the legs couldn't get a grip, and so it's bounced.
And we had no idea what's going on, where we would jump and how we would land and when we would land.
Oh dear.
Philae had crashed off the face of the comet and bounced about 1 kilometre back into space. Any further, and it risked escaping the comet's weak gravitational pull and drifting off into space forever. Anxiously, they waited.
We had no idea whether this would be a successful mission or would be just a touch and we would never again hear from the landers.
And then the news came in.
So we did land somewhere and we still had radio contact. We still received signals, and this was the moment of great relief, because that was the moment where we knew we are at the surface and we can still communicate with the lander.
But the good news didn't last long. It had landed in the shade. Not great for something reliant on solar power. This meant they had less than 72 hours of battery time to undertake months' worth of scientific collection. The clock was ticking.
So it's one of those things, it's like, okay, let's just throw away 10 years worth of calculations and let's just redo them all over the space of 5 hours, which is what they did.
We also optimized the sequence in a way to get the maximum science out of the energy available.
Once they knew they'd only got 70 hours and it was just going to seep away, it's like it wasn't if you turned all the instruments off, the battery would stay at that particular level. No, because it was so cold, it was having to maintain, it was having to keep heaters on as well, you know, to make sure that the instruments kept working. So you just knew you'd got 70 hours full stop, all right? So you worked for 70 hours. You just did it. You just barreled through. Get as much data as we can.
And amazingly, almost all of the instruments on Philae had survived the impact. It was go time.
We were very lucky. I mean, we ended up in an orientation that the antennae were pointing, upward, so to say, that we could establish a radio link with the main spacecraft. And again, we were also lucky because we could switch on the instruments. We could do fantastic science from the surface of the comet.
About 80% of the science goals of the Philae lander were achieved. So it was an absolute fantastic success. You know, the fact it crash landed, got around that. It was an amazing success.
This was, of course, a bit sad to see the voltage of the battery drop and knowing that Philae will go into a hibernation.
And eventually, that's what happened. But even in those few hours, Philae had unveiled a world full of surprises. Of dust and debris, gases erupted from deep within the comet. Even the crash landing threw up interesting discoveries.
Even by analyzing the bounce itself, we got information on what's the surface made of. And it was a bit surprising that the surface was rather hard.
But perhaps most exciting of all was what this comet was able to teach us about us.
The Rosetta mission had as one of its goals to understand the building blocks of life.
Because Comet 67P was rich in organic compounds like phosphorus, carbon, oxygen, nitrogen, and the amino acid glycine, all essential for the origins of life, and offering tantalizing clues as to how these compounds may have arrived on Earth in the first place.
So the original building blocks of life came from comets.
While Philae had gone into eternal hibernation, the mothership Rosetta continued to fly around the comet, collecting data for 2 more years. But then, Rosetta's time had to come. In a last-ditch effort to get as much out of the mission as possible, the team decided to crash land Rosetta into the comet. Collecting data along the way, and allowing the scientists to get one last look at their old friend Philae.
Took this sort of shallow dive onto the surface of the comet and then sort of crash landed, and its camera was going the whole time. So we saw these last pictures of the surface rushing up to greet Rosetta. And then the signal died, and you got this little sort of oscilloscope thing with nothing on it. Just like, you know, like somebody when they die and you see the signal die on the heart thing. And it was just like, it was so devastating. People were in tears, I cried. And it's just, hell's teeth, it's a robot, you know. But it's been part of your life for so long and so important. So that was it, that was the end of the Rosetta mission.
There is still many publications done using the data from Rosetta. That's still the most relevant and best scientific information we have from a comet.
Rosetta completely transformed our view of comets.
To some extent, what we know about the evolution of the solar system and what we believe about the formation of life, all of this is triggered by Rosetta, and this is not often in lifetime you get a chance to get involved in such a project.